What's up, guys, and welcome to this concept video. Basically, we are going over kinematics. Okay, so before we can go over what kinematics is, it's a fairly large section in your final exam, possibly up to about 30, 40, 50, 60 marks. So it's a nice long section, but it's quite easy, and once you get the basics, then there's nothing too difficult about it. Okay, but to understand what kinematics is, okay, so what is kinematics actually? So kinematics speaks about the motion of an object. Okay, so basically what we're trying to do is understand the motion of objects. Okay, but like all good things, we need to start off with some definitions. Okay, so the first thing we need to know is what is a physical quantity. Okay, so a physical quantity is a property of an object that can be measured using a measuring instrument. Okay, so what kind of things are these? Okay, so let's think of some examples. So examples of physical quantities, we can say length. Okay, so how do we measure length? Let's say with a ruler or a tape measure or something like that. Then we can have temperature. Okay, how do we measure temperature? Using a thermometer. Okay, so what else? We can weight. Okay, we can say weight is another one. Okay, so all of these things we can measure. Okay, another one that we can give is time. Okay, so a physical property, so a physical quantity is a property of an object that can be measured using a measuring instrument. Okay, there are some examples. We'll go through some more. Okay, now what we need to know is the difference between a scalar versus a vector. Okay, so there's two physical quantities or two ways of describing physical quantities, either as a scalar or a vector. Okay, so for a scalar, we can say that it's a physical quantity with magnitude only. Let's actually, okay, only magnitude. So an example of this would be time. Okay, so by magnitude, okay, let's actually go through what a vector is. Okay, so a vector is a physical quantity that has both magnitude and direction. Okay, so let's just look at these four that we've written down already. Okay, length, a scalar or a vector. Okay, so if we're, let's say, standing on a track and we give a reference point, okay, so this direction we can say is positive and that direction is negative. Okay, so length would be a vector quantity. Okay, it can be positive or negative. You can go forwards or backwards or left or right. Okay, if we look at temperature, okay, don't be fooled that temperature, the SI units or the scientific units are Kelvin. Okay, Kelvin. You cannot get a negative temperature. In degrees Celsius, you can get a negative degrees, but you cannot get a negative Kelvin. So, so temperature would be a scalar. Okay, when we speak about weight, what we're speaking about are forces. Okay, and you can have positive or negative forces, so this would be a vector. Okay, in time, I know it would be really fun to go backwards in time, but we can only go forwards in time. So time would be a scalar. It only has magnitude. It can only be 10 seconds. You can't have a negative 10 seconds. Okay, another example, let's see, what else could we say? Energy. Okay, so energy. Okay, energy again is a scalar. We cannot have a negative energy. Okay, so those are a couple examples. So the most important part basically is that a scalar has magnitude only and a vector has both magnitude and direction. Okay, and we'll be going over a couple of more physical quantities and just deciding whether they are vectors or scalars. Okay, so here we go, more definitions. Okay, so position. Okay, so what is a position? Position is an object's location relative to a reference point. Okay, so what does that mean? So let's say we have a racetrack. Okay, and here's the starting line, and we have a car. Okay, cool stuff. So we can define this as the reference point. Right here where the car starts at the starting line, we say this is the reference point, and we give it a value of 0 meters, okay, because we're deciding on direction. Okay, so when the car is here, okay, when the car is here, it's some distance from the reference point. So it's some, let's say, 100 meters from the reference point. So its position at this point here, the position of the car equals 100 meters. Okay, so what happens if for some reason the driver has put the car in reverse and he ends up going backwards a bit, and the driver ends up right here? Okay, so if we looked at this position, okay, so this distance, we can say that at this place the position equals 50 meters, but we need to give it a direction, so it's a negative direction. So what we say is that we take the right hand side as a positive direction, and if he goes in reverse, if the driver goes in reverse, they are going in the negative direction. So what can we say about position? Position is a vector quantity. Okay, so so frame of reference is what we've basically spoken about when I talked about the reference point. It just speaks of a set of directions. So we can define them. So a frame of reference Okay, I'm not going to really define it because there's no real definition, but basically what we use a frame of reference for is to give direction. So we can say that's up and down. Okay, alternatively, we can say that's north or south. The same way we can say this is left and this is right. Or we can say that this is, what's that, east or west. If something is rotating, we can say that it is going clockwise, or it can be going in the opposite direction, which would be anti-clockwise. Okay, so we can have different frames of reference. Yeah, but those are the ones that you'll most probably come across. North, south, east, west, up, down, left, right, yeah. Okay, and then rectilinear motion. Okay, so rectilinear motion speaks of straight lines. Basically, it means motion along a straight line. Okay, so rectilinear motion can be horizontal motion, so it can be rectilinear motion can look like that, or it can be up and down motion, vertical motion, so it can be horizontal, so vertical. So we can get vertical rectilinear motion, or we can get horizontal rectilinear motion. We're probably going to deal with horizontal in this case. Okay, so let's do an example that speaks of that has to do with position. Okay, so let's do examples in orange. Okay, so something I didn't actually speak of is that if we had the finish line over here, we could always choose this as our frame of reference, or our reference. Okay, and then what that means is that the car starts at, let's say, minus 100 meters. So you can choose any point as your reference and just keep it constant. So if we chose the orange as our reference point, then the start position would be, let's say, minus 100 meters. Okay, so that's what we're going to do here. So let's say we have three buildings, 1, 2, 3. Okay, so we have a hospital, a school, and a fire station. Okay, so let's put some distances in here as well. So let's say that is, let's stick to that color actually. Let's say the school and the hospital are 100 meters apart, and the school and the fire station are 75 meters apart. Okay, so what we want to understand is different reference points. Okay, so in this example, what we want to do is have different reference points. Okay, so I am going to say, if we wanted to go, how do we get from okay, so from and then to somewhere. Okay, so basically we want to know the distance from to, and we need to, so from, okay, so let's say from to, and then let's have a column for the distance. Okay, so if we want to get from the hospital to the school, okay, so in this case, my reference point is the hospital. So how do I get from here, and I want to end up at this school? So this is my start, this is my end. Okay, so my reference point, or my reference, the reference point is the from. So I'm going from the school. So the reference is the school, from the hospital. My reference is the hospital to the school. So this is my positive direction. Okay, so to get from the hospital to the school is 100 meters, positive 100 meters. What if I want to get from the school to the hospital? Okay, so this time, let's say my reference point is the school, and I am going, okay, so I'm going to say that left is always positive. So I should say that right is always positive. So going in that direction is always positive. So now I'm going from the school to the hospital. So this time I'm going in the left direction. So I'm going minus 100 meters, or 100 meters left. And in this case, it was 100 meters right. Okay, and let's say the last one is from the fire station to the hospital. Okay, so this time I'm starting at the fire station, and I want to go and end up at the hospital. Okay, so again, I'm going left, so it's going to be minus 175 meters, or 175 meters left. Okay, so what we have here is we want to show that the pluses and minuses actually give us these directions. So plus is right and minus is left. That's probably the most important part or takeaway from this. Okay, and from that we go on to some more definitions. So we need to know the definition of distance. Okay. So distance, the definition for distance is the length of the path traveled. Okay, so you're going to end up always asking yourself, is something distance or is it displacement? Okay, so what is displacement? Okay, so displacement is a change in position. Okay, so let us actually try understand the difference between these two. Distance in blue, displacement is in red. Okay, so let's say you want to go from, let's say this is your situation that we have here. You start at school and you want to get home. Okay, but on your way home there is a shop. Okay, so this is the path that you take. Let's say this is 100 meters and this is another 100 meters. Okay, so on your way home, this is what you look like. So you have yourself going home. So you go to the shop, and once you get to the shop, you actually see, oh no, I forgot my wallet at the school. So you have to go all the way back to the school, and then you go back to the shop. Once you go to the shop, you buy some stuff at the shop, and then you go straight home so that you can eat whatever you bought. Okay, so that's what it looked like. That's what the whole path looked like, right? So that means the distance is the length of the path traveled. So the distance is the complete length that I've traveled. Okay, so how far is that? That's 1, 2, 3, 4 sections. We can break it up into. So section 1 was 100 meters plus section 2 plus section 3 plus section 4. So that's 100 plus 100 plus 100 plus 100, which is equal to 400 meters. So that is your distance. It is the total length of the path traveled. Okay, now your displacement is basically your end position minus your start position. Okay, and notice that distance, which is in blue, is a scalar. I did not care about the fact that I went, if we're taking that way as positive, I don't care that I went forwards, positive, 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 then went negative, negative, positive, positive, positive. I don't care. All I care is how far the person actually traveled. So for distance, we're always working with scalars. Okay, and for displacement, I'm sure you've guessed it, it is a vector. It only cares about the end minus the start. So I ended up here, this was my end position, and this was my start position. What is the displacement between that? It is 200 meters, or we can break it up. You went to the shop. The fact that you went back and came means absolutely nothing. You then resume. Oh, sorry, I'm erasing stuff. You then resume and you ended up at home. So 200 meters, and because it's a vector, we need to give a direction. So 200 meters right. Okay, so a very interesting situation comes up with these questions. So let's say that you are an extremely good athlete and you've decided to run track. Okay, so we have a track right here. Okay, so we have the start, and let's say it's a 400-meter track. Okay, so you start right here. You need to do one lap. So you start, you get going, do all the way around the track, and then you end up back here. So you end up back there. So the question is, what is my distance and what is my displacement? Okay, well, the distance is the length of the path traveled. So if I have a 400-meter track, that means that I went all the way around and I ended at the start, so I went 400 meters. What about my displacement? So my displacement, like I said, is equal to my end position minus my start position. So I ended right here, and so this is my end, and what do you have it? This is my start as well. So that means my displacement is 0 meters. Okay, so basically what we can say is that the person has had 0 displacement, but that doesn't mean that they haven't moved, because they've done the 400 meters. So their distance is 400, but their displacement is 0 meters. Okay, so let's build up on this and just get some understanding between the two differences. So with displacement, I'm sure you guys will agree that it depends on the path. Okay, so it depends on the path. If I decided that I'm going to run like this up and down the track, then my distance is going to be much larger because I'm running weird. Okay, but for displacement, it is independent of the path. Okay, if even if I ran like this, I ended up at the same position, so my end minus my start is 0, so it doesn't matter. Okay, so with distance, we always have positive, always. Okay, so you can never get a negative distance because it is a scalar. Okay, but for my displacement can be positive or negative. Okay, and we saw that in the first example. If you ended up going from the fire station to school, we ended up with a negative distance. Okay, and the third thing, or the third difference, okay, so obviously point 2 leads to point 3. Distance is a scalar, while displacement is a vector. Oh no, I've made a mistake. In red, there we go. Okay, so I don't know if you guys want to take that down, take a screenshot or something like that. Let's see, how long is this video? Okay, it's getting pretty long, so I'm going to end this video, and in the next video we are going to go over speed versus velocity. And I'm sure you guys have guessed it, one of them is a scalar and one of them is a vector. So thanks for watching, guys. Yeah, hope you found this useful.